This research started out with an interest in looking outside of finance and how tests were actually done. So there's a very disturbing conclusion in the medical research that most of the tests that are published are actually wrong. So it's very disturbing because lives are at stake. So I got very interested in whether some of these techniques that are popular in medicine and other sciences actually apply to finance. So another place I actually looked that's rather interesting is the discovery of the Higgs boson, which happened in 2012. And this involved enormous expenditure in terms of building this collider in Europe. It was over $5 billion. But the actual discovery of this particle was very difficult because there were quadrillions of tests going on. So the scientists had to be very careful because a discovery just might be by chance and it might not be the Higgs. So they established criteria which seemed very stringent to actually have a true discovery. It's also true in genetic research where there are at least 20,000 genes. And you're trying to find an association between a gene and a disease. So there's 20,000 different possibilities. Just by chance, you're going to find something that looks like this gene is associated with this disease. And to make it worse, it's not just one gene, it could be a combination of genes. So you put all those combinations together, and it's very difficult. So there's a paper published in Nature recently that looked at 500,000 combinations of genes and linking to Parkinson's. So again, they had to be really careful in terms of what they did. 500,000 times, you're going to get some association just by chance. So these ideas directly apply to finance because we're out there trying hundreds, thousands of different investment strategies. And just by chance, some of them are going to look good. That's where my research actually comes in and establishes some new rules of the game. If you do just one test, we've got a way of figuring out whether the result of that test, and it might be an investment strategy, is what we call significant. And really what that means is that there's a very small chance that this good strategy is actually a dud. Now suppose you try 20 things and you find one looks good. Well, that's a totally different game because if you tried 20 of them, then one of them might look good by chance. And that's where my research is actually coming from. That the more that you try, the higher the probability that something is going to look good by chance. So in order to establish that this investment strategy is a strategy that is real, something that will actually work in the future, you have to have a hurdle that is much higher than the usual hurdle that we use. Just like in physics, when they're trying to discover the Higgs, or in genetics, where you're trying to find an association between a genetic structure and a disease, you have to allow for the possibility that your finding is by chance. So the hurdle becomes much higher. Unfortunately, in finance, we haven't figured this out. And my research basically is trying to establish new guidelines. What I do is establish a method so that the researcher can adjust the hurdle that the investment needs to exceed based upon an estimate of the number of things that was actually tried. So if you go in and you just tried one thing, then you could use the standard criteria that we've been using for years. However, if you've tried 100 or 1,000 different iterations, then what my paper does is says, well, this is what you have to do. So it sets new rules of the game. It's very common that an investor is presented with a product that has been historically back-tested, which means it hasn't really been running with real money on it, but the researcher will create a simulated strategy based upon the past data, and it might look very good. And the investor needs to choose whether to put money on this. Or it might be within like an investment company where they're trying to build a strategy to sell to individual investors or to institutional investors. And they're trying to put together the best possible strategy. A researcher within that organization is presenting a strategy. Now, the superior needs to know how many strategies have been tried before you get to the one that's being presented. That's really important because the more that are tried, the higher the chance that what's being presented is just lucky. Okay, so it needs to be taken into account. And then the third dimension is the institutional investor. That could be a pension fund, for instance, and somebody's pitching a product. And again, it's based upon a historical back test, we call it. And again, that investor needs to be very careful. They want to do what's best for their pensioners. So they need to separate out the luck from the skill, so to speak. And if somebody comes in with an investment product where you know 1,000 different things have been tried, then you need to adjust your criteria. So this is the practical implication of my paper. The bottom line really is that most of these things that are presented to investors are probably false. And that's kind of shocking. But practically speaking, what I try to do, I can't do anything about the past, but what I can do is provide these new guidelines for the future. A lot of people, what they like to do is to detect luck from skill. What they'll do is a so-called out-of-sample validation. So this is an idea whereby you hold out some data and you test your strategy or your investment on, let's say, half the data, and then run it on the other half as an out-of-sample validation. If it works in sample on the first half and it works out of sample on the second half, then you've got more confidence that it's not just luck. Now, there's a lot of problems with this, and I could list just a few. For example, the early part of the data, the first half, you might not actually have enough data to detect a valid strategy. So you might discard it. So it's gone before you get to the other sample. On the other hand, you might have something that's really a genuinely good investment, but the out of sample period is so short that you don't have time to validate it. So it's discarded, it's lost. Another problem is that you actually know what's happened in the past. So even if you split your data, you actually know what's happened, let's say in the last 10 years. We had a financial crisis, you know that. So you know variables that work, variables that don't work. So it's not really out of sample. And the worst thing that can happen is that you try an investment strategy on the first half, it doesn't work on the second half. Then you go back to the drawing board, try something else, and then it doesn't work. You try something else until it does work. And that's not out of sample. That's just bad research. So there's a lot of issues with this. It is definitely not a panacea. Indeed, the only true out of sample is from today going forward. But that doesn't help you that much. If you're an investor, you're presented with a product, and it looks good, you need to make a decision. You can't say, oh, well, come back in 10 years. No, you need to decide in real time. And what my paper does is provide a way to do that in real time. I think that people need to be a lot more skeptical of these proposals of investments that are made all of the time. In my teaching, I give an example of somebody trying to become your investment advisor. And what they do is they say, look, I'm going to convince you that I'm really good. So I'm going to send you an email at the end of the month. And I'm going to make a recommendation on the stock market for the next month. And I'm going to say, it's going to go up or it's going to go down. I'm going to do this every single month. And you judge my record. So the first month, I get the email, it says market's going up, it goes up. Second month, the email says market's going down, it goes down. And I just keep on getting these emails, and I get 10 in a row, every single one correct. This guy is great. So I switch my money to this investor. Then I realized that things don't go that well. And I learned the hard way what the strategy was. So the strategy was simple. You take 100,000 emails, and you send out 50,000 of them saying the market's going up, 50,000, the market's going down. In the first month, the market goes up. You discard the 50,000 where you got it wrong. You go back to the 50, and half them you say it's going to go up, half them you say it's going to go down. And again, you keep on splitting the email until at the end, in the 10th month, you've got 97 people that get exactly correct, 10 in a row. So when I look at it, it looks great, but once I know the strategy, basically 100,000 tries, then I know this is just luck. It has nothing to do with skill. So I think people need to be a lot more skeptical about these findings, and I'd actually provide some guidelines, as I said, that could be useful for them. It's really interesting because I thought that they would take this very negatively. Because effectively I'm saying half the things you're selling are probably false investments. False meaning that the promise is not going to be fulfilled. And I was quite surprised at the finding, but the more I thought about it, the more it made sense that the reception was very positive. So maybe it's simple. These firms actually want to do the right thing for their investors. So they promise a return. They actually want to deliver that return to the investors because it builds their reputation, it attracts more investors, and maybe most importantly, they get paid directly if you make the money. So it's in their interest to get it right the first time. They don't want to go to clients with strategies that are fleeting. So they've very much embraced my research, and a number of very large investors have actually contacted me saying that your criteria is now our criteria. So that's kind of reassuring. So this is something that I think is a positive for Wall Street firms or investment banks, as well as all the way down the line. It just affects how we do our research. And I think that's very important, not just as an academic, but as somebody that cares about people when they invest their money getting what they expect.